All right, so yesterday we talked about a segment like that blue one there, okay? In that blue segment, let me change the color, make it a little bit easier to see maybe. That segment there is a segment that starts at a vertex and goes to a midpoint, right? When that happens, what do we call that segment? We call it a median, okay? Therefore, that one is also a median, and that one there, also a median, right? So you got those three medians, and they're medians no matter where the vertices of your triangle are, okay? That point of concurrency we talked about as being the centroid. Now, when we talk about the centroid and use the centroid, okay, maybe changing the color of that might be a little easier to see it too. All right, so dealing with the centroid, we know that through the theorem that was provided yesterday, and we didn't prove the theorem, but through that theorem that was provided, that the centroid is always going to take your medians, no matter which ones you look at, and it's going to divide them into two parts, okay? The two parts that we first look at are those two, okay? And the data, or the ratio that is provided by looking at those two is not described in the theorem. The theorem says there's a 2/3 ratio between things, okay? Well, the 2/3 ratio will show up here in a moment when we talk about it, but if I look at just those two parts, and I compare those two parts, how do those two numbers of 4.84 and 2.42 compare to one another? Yeah, this one here is half of that one, okay? So that means the red one is always going to be half the green one. And no matter where I put my vertices, okay, that relationship still exists, okay? So when we look at this comparison, we call the green part a vertex to the centroid, okay, because that's what that segment is defined by as regards to its endpoint, the vertex and the centroid. The red part is the centroid to the midpoint, okay? When we look at that comparison, when we use that comparison, it's always going to be a 2-to-1 ratio, okay? And when we look at it, let's see if I've got vertex to centroid. Yes, vertex to centroid is always twice as big as the centroid to midpoint. So I've got that in the right order, 2-to-1. If I compared it centroid midpoint to vertex centroid, it'd be a 1-to-2 comparison. Does that make sense? So when you do a comparison, the order comparison is does have some importance. Now we look at these two numbers. Okay, now it's kind of a pain in the butt to see here, but this is the only way that I could do it. Anything that is dark blue or has any dark blue on it is that EA. It's the entire median, right? Okay, and then the dotted blue is the centroid to the midpoint. Okay, and that is overlapping this big blue distance. So what we're looking at ultimately is the comparison of this everything that is dark blue to now just that little red distance. Does that make sense? Okay. The only way I can show that though is to overlap it this way. If I look at these two numbers, now it's not a 1-to-2 relationship anymore. Okay. Any ideas on how much I have to magnify that number to where I can get that one? Times 3. Okay. I need this one here needs to be enlarged 3 times to get the entire median. Okay. Or this one here needs to be divided by 3 to get this little distance here. Okay. So that is, I believe I got another comparison too. Yes. Okay. This is a centroid to a midpoint. Centroid to a midpoint. So it's that little dotted distance. Compared to the whole median. The whole median is A to E. It's everything that's dark blue. Okay. When I compare those parts, I get a 1-to-3 ratio. It's always a 1-to-3 ratio when I compare those two parts. If that's 1-to-3, so meaning this is 1/3 the entire median. How much is that of the entire median? 2/3. So that's where the 2/3 from the PowerPoint yesterday and the theorem yesterday shows up. Is if we look at those distances. Okay? which in the theorem it says the distance from the vertex to the centroid is always 2/3 the distance of the entire median. Okay? So this yellow dotted distance is 2/3 the entire median. If I look at that, the way that we could kind of explain this is if I take this number here, this is the entire median, multiply it by 2/3, it's going to give you that number there, right? Okay? Or if I take this number here and multiply it by 3, multiply that number by 2, what those values equate to, what those products are, should be the same. Okay? So when you compare a vertex to a centroid, that distance to the entire median or the whole median, you're always going to get a 2-to-3 ratio. Okay? Is that all right, everybody? Hopefully you have those comparisons, those three comparisons in your notes. Somebody asked earlier today if I would post this GeoGebra on my website, and I will. I just haven't gotten to it yet. Okay? But hopefully maybe I'll do that by the end of the day. The reason I want you to have these comparisons is we are going to, every time we see a problem in our homework or hopefully on a test or a quiz, we've already got these kind of memorized from a test or a quiz, is that we're going to compare our picture to these three things and decide which one of these relationships do I have. Do I have that relationship? Or do I have that one? Or do I have that one? And that's going to allow me to pick off the right multiplier for our equations. Okay, so we did one example yesterday. I want to do two more today, and then I want to talk about a concept in the coordinate plane for centroids. So I'll give you a minute to write that down. When you look at this problem, what kind of point, and I guess I didn't say this in the direction, hopefully we all realize these are medians, right? Okay, so what kind of point is that if these blue segments are medians? Centroid, okay? I will make it a point not to tell you that that's a centroid. Okay, I will make it a point to say the blue lines are medians, or make it a point to tell you that B and C are midpoints, so that you are forced to learn your vocabulary and understand how they interrelate and interact with one another to create other objects. Okay, so when you get to homework, tests, quizzes, that kind of stuff, understand that I'm going to phrase my questions so that you can answer them if you know your vocabulary. If you don't know your vocabulary, you're going to struggle on that stuff. Okay. And people always say, well, why are you so hard on vocabulary all the time? It's because we need to have meaningful conversations, right? That's what education is about, to learn something, to have meaningful dialogue. And if you don't know what I'm talking about, can that be a very good discussion? No. Does anybody speak French in here? Parlez-vous français? Si. So if you don't talk French, and I just start talking French, you're going to have a problem with that dialogue, right? Having a problem having that conversation with one another. So if you don't know the words being used, you can't gain anything from that conversation, okay? So learning our vocabulary allows us to have that dialogue, okay? And it allows us to be able to relate things. So, it's not that funny. All right, so the reason we have point V there and that other median there is so I know that V is a centroid, and then when it's a centroid, we know it should address these ratios. We should get those to develop. Okay? Now we have to decide which one of those is best to use. Okay? So you can't just haphazardly choose the 1/3 because I think that's the one, or 1/2, or 2, or 2/3. You have to have concrete reasoning or logic behind that. Okay? So what you're going to do is you're going to look at the parts that they give you. They give you JC and VC, right? So I'm going to highlight JC, which will be that blue segment, and I'm going to highlight VC, which would be the red one, right? Those are the things they're asking me to compare. So I need to create an equation with those things. Okay, so JC, I let be blue, VC is red. Now, are they equal to one another as JC and VC? No, okay? They are, obviously you see one, the size is different. That's why I highlight them. They recognize, well, they're not the same. So I can't just arbitrarily say -4 plus 2x equals x minus 3. That doesn't make sense. So I need to be able to either take the blue one and turn it into the red one, or take the red one and turn it into the blue one. Does that make sense? If I were to take that blue one and turn it into the red one, what has to happen to that blue distance? Okay, I've got to multiply it by a fraction that's going to shrink it, right? Any number between 0 and 1 will shrink it. So if I give you the number, let's say that blue distance is 12, and I ask you to multiply it by 1/2 or 2/3 or 1/3, think about doing it. Multiply by 1/2, that 12 turned into 6, right? Multiply by 2/3, multiply by 1/2 and 12 turns into 6. Multiply by 1/3 and 12 turns into 4, right? Multiply by 2/3 and 12 turns into 8, correct? Each time that I multiplied by that, one of those fractions between 0 and 1, it took 12 and made it some smaller value, right? Okay? So if I want the blue one to turn into the red one, I have to multiply by the blue one by one of those fractions. So there needs to be a multiplier right there. Okay? We now have to decide what multiplier is that. Okay? So now you look at your picture and say, okay, what part is the blue one? What segment is that blue segment? What do we call that? It's the median. And it's the whole median, right? And we're going to compare that to the red. What is point V on the red one? Centroid. And it's going to go to, what's C? Midpoint. Okay? So now we're going to grab our comparison chart, and we're going to look at which one of these three comparisons is defined here in that picture. We're looking for median compared to centroid to midpoint. So centroid to midpoint, it's either this one or that one, right? Which one compares the whole median to it? Comparison 2. So now with comparison 2, we see it's got a 1-3 ratio, right? Okay? So a 1-to-3 ratio, so that's the fraction that I'm going to use. So that's the fraction, and it needs to go right here in front of JC so that it shrinks JC. Is that all right with everybody? Now, if you're a person that doesn't like to reduce things, multiplying by a fraction is just division, right? Multiplying by 1/3 is simply dividing it by 3. Okay? If you don't like that and you prefer to multiply, could I take the red one, and what would I need to multiply the red one by to make it grow into the blue one? 3. So I could say that 3 VCs should equal 1 JC. And now my question is that really anything different? Are those two things different, or are they the same? They're the same, because when I look at this one, my first step, whether I substitute first or do that second, is to get rid of that 1/3, right? So I multiply both sides by 3. Does that give me JC is equal to 3 VCs anyways? Okay? So that's what I suggest doing when you write your equation. If you have fractions in your equation, go ahead and multiply by that denominator to get rid of fractions before you start substituting. Okay? Now, some people are going to want to jump straight to just writing the equation out and not writing the 1/3 JC equals VC. That's your prerogative. That's your choice. But here's my suggestion to you. Pay attention to your success rate on questions like this when you do that. If you're doing that and you're continually getting these wrong, should you try something else? Yeah, you should probably say, okay, let's slow things down a little. Let's be a little bit more deliberate with the way we write our equations and then see if that helps increase my success rate with them. So now I substitute. So JC is -4 plus 2x. I've got 3 VCs, which was x minus 3. Every time I do this, so this was the geometry. This is what I was trying to teach you yesterday. Okay, if you could do that, you've learned the geometry. You've mastered that. Let's now go through the algebra. What should I do with that 3? Distribute it. All right, so now I want to add 9 to both sides. Subtract 2x from both sides. Gives me x to be 5. You guys agree with that? Okay. You should be able to, on your homework, before you hit submit on any of these questions, you should know whether you've gotten that question right or not. On a test or quiz, if I gave you just a quiz where I got 10 of those on there, you should know when you hit the submit button, your grade before it even grades it. Okay? Because you should be able to take that 5. Plug it back in here. What's that give me if I plug it back in there for JC? Gives me 6. When I plug it back in here, what's it give me? 2. Now, got to follow with me here. 2 divided by 6. What's 2 divided by 6? 1/3. Now, that 1/3 showing up is nice, okay? But because it's the 1/3 that I used in my equation, that check really only tells me that I solved that equation correctly. It does not tell me that I set the equation up right. Does that make sense in regards to the picture? But if that's 2 and that's 6, what is this? This is J to V. That's 4, right? Now, did I ever use JV compared to anything in creating my equations? No. But what's 4 compared to 2? Okay, I'll go 4 compared to 2 would be 2. But 2 compared to 4 would be 1/2, right? So when we do comparisons, just the order in which we state them is important, because otherwise you're going to get the reciprocal. But I either get 2 or 1/2, right? That's that fraction right there, isn't it? Okay. And didn't we say that when I compare a part to a part, there's a 2 to 1 or 1 to 2 ratio? What is 4 compared to 6? 2/3, right? I never took JV and compared it to JC when I did my equation. But when I get values back from this equation, that when I plug back in here, produce that 1/2 and that 2/3, that confirms that I've got the right equation, and at the same time it confirms that I've got the right solution for that equation. Does that make sense? Okay. I think a lot of times, which is good, we're checking our algebra, that's awesome. Okay. But I think a lot of times we go back through and we check our algebra, and it works. It shows us that our algebra was right, but the equation that we had to set up on our own doesn't really target the question that's being asked. So that's always something to kind of think about and realize how we can address when we're checking our problem. Is that okay? All right, so let's do one more of those. You meant to write that down. All right, so when we look at this, the point in there, I, what is I, if those are all medians? That's my centroid. And again, the purpose of all 3 of those medians being in there is just to remind me, or to show me that relationship, that is the centroid, and that those 1 to 2, 2 to 3 and 1 to 3 ratios are present based off of that point right there. Okay? I erase the other ones because I don't need, if I look at, I read this, UI and IR, those are only segments that they're talking about, right? So I don't need S to V and S to I and all that kind of stuff, so I just erase them. IR, that red distance. U to I, that blue distance. If I look at this, okay, so IR and UI are the things that I'm trying to equate to one another. But again, my hopes are you recognize they are not the same, right? Nowhere in our theorem have we said anything is always the same in that relationship against the centroid. Okay, it's always 1 to 2 or 1 to 3 or 2 to 3. So directly nothing is equivalent. Which one of these do you want to manipulate? Which one do you want to change? IR? Okay, so if I want to change IR, I'm going to have to put a number out front, right? Now I got to decide what number. Do I use 1/2 or 2, 1/3 or 3, 2/3 or 3/2? Okay, so we got to go back and we're going to look at this. IR is centroid to a midpoint, right? This one here is centroid to a vertex. I'm not looking at the entire median, correct? So I'm going to go look at my comparison chart. And that one talks about the whole median, so I'm not using comparison 1. That one talks about the whole median, so I'm not talking about comparison 2. This one is the one that says vertex to centroid, centroid to midpoint. That's the one I'm using, 2 to 1. Okay? So that's 2 to 1. So I'm going to use that ratio, or 1 to 2. But now I got to decide which version of it do I use. Do I use 2 over 1 or do I use 1 over 2? And you said you wanted to impact the red one, right? We want to change the red one. We'll manipulate that one. So is that bigger or smaller than the blue one? It's smaller. So what do I need to do to make it equal to the blue one? Make it bigger. So what do I need to multiply by? 2. Okay. Is it equal to say that 1 IR is equal to 1/2 UI? Yeah, that example there, IR equals 1/2 UI, is actually taking UI and shrinking, taking the blue one and shrinking it down to be equal to the red one. Okay? But if you wrote that one, my hopes are the first thing you would do is get rid of that 1/2 by multiplication of 2, right? When I multiply by 2, we get the one that Alex said we should have. 2 IRs is equal to 1 UI. 2 IRs. So 2 x plus 1s should equal 3x. And again, hopefully that algebra is not anything that's extremely taxing for us. X is 2, right? If x is 2, what's UI? 6. What's RI? 3. What would be R to U then? 9. What's 3 compared to 6? 1/2. That comparison tells me that I solved that equation right. What's 3 compared to 9? 1/3. That's enough to tell me that I actually have the right equation for this picture. If I want to go a little bit further, what's 6 compared to 9? 2/3, right? Does that phone up there keep beeping, or am I hearing things? Yeah, you're probably hearing. It's beeping? All right. There's times that I hear things, so. I did it? Okay. All right. Let's do. So what I'm hoping you guys see is that in your homework on tests and quizzes, you're gonna be jockeying back and forth between a 2/3 ratio, a 1/3, and a 1/2. You might see 4 questions in a row that you use a 2/3. On the 5th one, you might use 1/2. Okay, so you might get in a mode that says, okay, I'm doing the same thing over and over again, and then they throw one in there that's a little bit different. Okay, we have to understand there's 3 options for us, and then how we can address those. Yes.
Can I do this on the board? I already did my homework, so.
Huh?
Can I do this on the board? I already did my homework.
Do what on the board? Oh no, we already did this one.
Oh, we did?
We did this one yesterday. We're going to do something a little bit different. Okay? We're going to look at it, and actually I want to start with just looking at GeoGebra real quick. All right, so I want to walk through a process with you that you guys you've demonstrated that you can do this, okay? Where we take the equation of a median, okay? So let's say I take the equation of that median right there, and then I take and find the equation of that median. If I set those two equations equal to one another and solve for x, I should get the x coordinate of where my cursor is, right? That's the centroid. I should be able to take that x and plug it back in to one of my equations of dotted lines and find my y, right? Okay? I want to work through with you the way that we can find the equation of that dotted line when I don't necessarily know or care even what the ordered pairs are of points A, B, and C. Okay? I'm just using generic letters. A, comma D for point A, B, comma E for point C, and C, comma F for point B. And because all of those, none of them use A again, none of them use B again, or C, or D, or E, or F, basically tells me that all three of those ordered pairs are just generic ordered pairs that don't have any relationship to one another, right? None of them are stacked on top of each other. None of them are horizontally aligned with one another or anything, okay? But they could be. Obviously, if I want to put that there, that could be, and then D and E could be the same number, but they don't have to be, okay? And I want to go through and I want to come up with an equation for this line. Now, it's going to get kind of messy, but you guys have all the tools to do this, okay? Remember, come up with the equation of the line. We're going to talk about this formula here. Y minus Y1 equals M times X minus X1, right? Okay. So if I find the equation of that line, it'd be Y. Well, let's do it this way. You need slope first, right? Okay, I'll try to find the dotted line. Well, that point right there is a vertex. We obviously know that. I would not know D right off the bat. D is the midpoint, right? And all I have right here are that point, and that point. And you guys, I don't know if I said this, you don't have to write this down. I want you to follow along. I want you to kind of immerse yourself in this and realize then the connection between this amount of algebra and the intense algebra we're going to go through here in a moment, and see what happens by having what the benefit of that algebra is in regards to a formula that's going to be generated here in a moment. Okay, we get a really, really, really nice formula that we can use to find the centroid, but its logic, its reasoning is because of some very, very intensive algebra that you all have the ability to do. It's just a lot of steps. Okay, if I got to find the equation of that dotted line. I need the slope. How many points do I need for slope? 2. Okay, so this point, CF, I knew. This one I didn't, but I know D is a midpoint, right? So I can take that X value, I can take that X value, and I got to divide by 2, right? I can do the same thing with that Y value, and I got to divide by 2. So now if I wanted to find the slope of B to D is going to be Y2 minus Y1. So let's let that be Y2. Let this be up here Y1. Well, I'd write that as D plus E over 2 minus F, right? That would be Y2 minus Y1. Does everybody agree with that? X2 would be that number. X1 would be that number. So I could take A plus B over 2 minus C. There is my slope for that dotted line. Why is it so weird? It's because now when I change it to there, obviously those slopes of those dotted lines are all different, right? Okay, and the A, B, C, D, and E's and F that are dictating the slope of that line come from these ordered pairs A, B, and C. So when we're done with this, I'll come back and we'll do a specific example using what we generate and see if that makes sense to us. See if the equation we developed is accurate for this picture. So now I got my slope. If I want to put this into, so that's going to go right there in my equation. I need a y1 and an x1, right? And a y1 and an x1 are going to be a point that is on that dotted line. That point's on the dotted line. That one's on the dotted line, right? Which one would you prefer to use? CF. That's a small. That's an easier number to manipulate, right? Okay. So when I write my equation, it's going to be y minus y1, which is f, is equal to m, which now m is this thing, d plus e over 2, minus f over a plus b over 2 minus c, times x minus x1. Well, x1 was c, right? So x minus c. Now, if I wanted to solve for y, can I add f to both sides? Okay, now this is ugly. What that is, okay, that is a formula, and we'll do a specific one here to show that this does make sense. I put the values of those points up there, and let me just move them a little bit so we have a little bit easier algebra. Let's move them to those grids. Let's actually make all right, that should be, well, there we go. So we're finding that dotted line, that equation, that dotted line. All right, so what happens here is with specific values, we see that A is 4, D is 2. Does that make sense? We see over here, B is 10, E is 6, and here, C is 6, F is 8. If I plug in everything, I get Y equals. Okay, so it's D plus E. D was 2, E was 6, so I get 8, minus F. F was 8, right? All over A plus B. A plus B. So A was 4, B was 10, so 14. Oh, I didn't divide that by 2, did I? It's 8 over 2, sorry. D plus E, so D plus E is 8. 8 divided by 2 minus then F of 8. Down here, A plus B was A is 4, B is 10. Add those together, you get 14. Divide by 2. Subtract from it C. C is 6. Okay. X is always X. Minus C. C is 6 again. And F then was 8, right? So there's an equation. What's 8 over 2? 4. What's 4 minus 8? Negative 4 up top, right? What's 14 divided by 2? 7 minus 6? 1. Okay. So what's negative 4 divided by 1? Negative 4. Okay. What's negative 4 times X? Negative 4X. What's negative 4 times negative 6? 24. So I get negative 4X plus 20. Was it plus 24? Plus 8 is, that should be a 32, right? I'm going to put a line in here real quick because GeoGebra will allow me to ask what the equation of this line is. Oops. In y equals mx plus b form, is it negative 4x plus 32? Okay, so what did we just do? I just kind of try to open your eyes to this. We took arbitrary values. I don't care what b is. Oops. I don't care what b is, a is, c is, as specific values, because when I move them, doesn't that line change? That dotted line change? It's a different equation, right? This thing here will generate all those infinite different equations. Okay? There is a program. So basically what we're going to do, we have that equation of that dotted line. I have a program that's going to do some algebra for us, and we can find the equation of maybe that dotted line. Okay? Or maybe that dotted line. And we can use then a system to help us see what that intersection point is. And it should come up with a really, really nice formula for us. Okay? So this is what I want to do. I'm going to draw a small picture here of what we just did. Okay, so let's say that this is, that was A, B, C, this was D, this was E, and that was F. And we came through, we found this equation, right? That was A plus B over 2, and this was D plus E over 2, right? So we'll find that dotted line, the equation of that dotted line. We'll find the equation of that dotted line. What I'm going to do is allow this thing, so I'm going to call it slope 1, okay? And all I have to do is type in the equation that we used to come up with the slope of that dotted line. So we said y2, so it was D plus E over 2 minus F divided by A plus B over 2 minus C. Okay, so just make sure I've got that typed in correctly. We're looking at, this is y2. Okay, so that would be that coordinate there, minus y1, which is that coordinate there, divided by x2, which is that coordinate, minus x1, which is that one, right? So we got the right thing there for ourselves. So if I hit enter, what this thing does, hopefully, maybe, unexpected parenthesis where? Good call. Gives me the slope. Okay? So it does that, it simplifies that expression. Does that make sense? Okay? Now if I want to go and write my equation of that line, okay? So my equation of that line is going to look like this. It's going to be, I'm going to call it y1, okay? It's equal to m, okay? Well, the slope I want to use is this slope, right? Times x minus x1. Well, x1 we said was c earlier, right? And then I had to add over my y1, which would have been f, correct? All right, when I write that, it gives me that equation. That equation is exact. It's a different form. They do a little bit of substitution, or sorry, simplification, but that's exactly what we came up with in GeoGebra right here. It's exactly the same thing as that. Does that make sense? Okay. So that is all algebra we could have done by hand, but allowing the computer to do it for us first. Now I'm going to find an equation for this line. So I'm going to find the slope of that line. So I need this, what's that going to be? A plus C over 2, A plus C over 2, and D plus F over 2. And then this point down here is BE. So I'm going to go through and find the slope of that one. Okay, so I'm going to say M2 is equal to, okay, now I'm going to go Y2, so D plus F over 2 minus Y1. Divide that then by X2, which is A plus C over 2 minus X1, right? So X1 would have been B. And when I hit enter there, that gives me the slope of this median. Is that okay with everybody? Now I'm going to write the equation of that median. So it'd be Y, we'll call it Y2, is equal to slope 2 times X minus, now X1. Well, I'm going to use this B. Does that make sense, everybody? And add over then my Y1, which would be E. And now I have an equation that is for that red dotted line. Does that make sense? All right, so the reason I've done it, so that's all algebra I think you guys have the ability to do, with at least with specific values of A, B, C, D, E, and F. Okay? What this program allows, it's called a computer algebra system. Okay? So it will do a lot of the algebra for us. So what I can do is I can ask this thing to take Y1 equal to y2. Those were my two equations, right? So when I type that, what it's doing is it's taking this expression here and setting it equal to that expression there. Does that make sense, everybody? That's a system of equations, right? y1 and y2 got to be the same y value, so these expressions got to be the same. If I do that and ask to solve for x, would you agree that that is a very simple leftover expression? So it runs through all, so it does all the combining like terms, it does all the FOILing, moving everything over to one side, and solves for x. And it gives me a plus b plus c over 3. A plus b plus c over 3. Well, look at what a, b, and c were, right? A come on, tablet died. There we go. A is that coordinate, B is that coordinate, C is that coordinate. What is the link between all of them? They're all what? X coordinates are my vertices, right? That formula is saying add them up, divide by 3, and that gives you the X coordinate of your centroid. Okay? Now, I'm going to do this. I'm going to allow that thing, I'm going to say, let's call that X. So say X is equal to that. So now I'm going to take, once I have an X value, right? Once I have an X value in a system equation, don't I just plug that back up into one of my equations that involves Y and solve for Y? All right, so I'm just going to substitute. I'm going to say, should I write Y2? All right, should we do it this way? I'm going to say just M2 times X minus B plus E. And now, wherever sees X is going to plug this thing in. I get that. Now, that's ugly, okay? But if I ask it to simplify that, and this is how I just recall the previous line. Simplify that. It gives me D plus F plus E all over 3. Well, what was D, F, and E? Those are the Y values of your coordinates, right? Okay? So, when they ask you guys to come up with a centroid in coordinate geometry, you've got two options. You can go through the equations of lines and all that kind of stuff and use the system. But you can also do this. The centroid is always located at x1 plus x2 plus x3 all over 3, comma y1 plus y2 plus y3 all over 3. Isn't that much simpler and easier? But I want you to understand that the reason you can do that is because of that algebra we did with the equations of the lines, right? And no matter what x1, y1, x2, y2, x3, y3 are, that formula is going to pop up. That's going to be the relationship that exists. And what I want you to understand is that your formulas that throughout math classes, throughout science classes, physics, that kind of stuff, they all have a background of something similar to that. Okay? And the more math that you attain, the more you start doing things like that with those programs. Okay? I took graduate level courses the last couple of years. I took 6 3-hour courses. 4 of them used a program like that, because the idea is we already know how to do the algebra. You graduated high school. You can do the algebra. Can we then allow a program to do the algebra faster for us so we can make better observations? Does that make sense? And quicker observations. So now when I do this, if I want to go through and figure out this centroid, let's add the x's up. What's that x plus that x plus that x? 3. What do you get when you divide by 3? 1. Add the y's up. 2 plus 2 plus negative 4. What's that give you? 0. What's 0 divided by 3? 0. 1 comma 0 is your centroid. Okay. If we look back to GeoGebra, just to give you another example of that. If I go back and ask for so I'm looking at points A, B, and C. Let's just put those at concrete values or specific values that we can add together pretty quickly. Look at these 3. What do I get if I add the x's together? I get 16, right? What's 16? I was going to type 16 divided by 3. Add my y's together. What do you get when you add your y's together? 15. 15 divided by 3 is 5. Is that the centroid? Is that where those 3 medians all intersect at either? Yes. Is that really quick to find that position? So much quicker than using our equations line. But I need you to understand that you can use that because of equations line. Okay? I'm going to leave last night's homework open. It's not going to be due tomorrow because there are some things in there about altitudes that you guys probably maybe don't have a full understanding of yet. So we'll talk about altitudes tomorrow, and then the next day that homework will probably be closed off. So it's not due tomorrow. It'll be due, tomorrow's Thursday? So we do Friday.